Alright, so welcome back, and here's another daily leetcode problem. So today what we're going to do is something called minimum operations to reduce x to 0. And so all that you want to do here is you're given x like so, which is initially 5, and we're also given this array called nums. And what you have to do is you have to either pick a number from the left side or the right side to basically subtract that number from x. So you could say 5 minus 3, or you could choose to use 5 minus 1. All right, so once you use that number, you can't use it anymore. So let's go say that you went ahead and you picked 3 here. And so next, what you have to decide here is, once again, do I want to take a number off the left side or the right side? And so here, now 5 minus 3 is equal to 2. And so then we want to pick either the left or the right. Say we pick the right side again, and we subtract 2 from it. It is now 0, which is kind of the end case here, right? Because we want to reduce it down to 0. And once we hit that, we basically just return the answer. But what we want to do here as well is we want to return the minimum number of operations that were required in order to reduce this number to exactly 0. All right, so we did that in 2 operations, and in fact, that happens to be the shortest path here. We could have decided, basically what this is a decision tree where we start at 5, we can choose 2 paths, left or right. We could choose either 1 or 3 here on the right-hand side, and this would reduce it down to 4, or this would reduce it down to 2. And then once again, these decisions would repeat, and we continue to have 2 decisions with each iteration as we go down the chain. Now, the issue with this is I believe this would be like 2 to the n factorial. Like, this isn't a very productive or efficient algorithm that solves this. And so we can actually do a little better using something called the sliding window technique. So this is a very common programming pattern. I highly recommend you practice a few questions using this technique before you kind of drill it into your head and keep remembering it. When you see these types of questions, you might be able to come up with this solution just by inherently understanding this pattern and knowing kind of when to apply it to different problems. But what this does here is, and I'm kind of expecting that you already know the sliding window pattern, and so if you don't, I would say look it up and then come back. But essentially what we're going to do is, instead of thinking of like bringing in from the outside inwards, we're instead of going to kind of slide a window and kind of organically grow and shrink it as we move along here. And so what this does is, instead we're going to say, okay, instead of kind of thinking about reducing x down to 0, let's think of what numbers we would need in a window that would inherently reduce it down to 0. And so what I mean by this is the total sum of this array here is, I believe it was 11, I counted earlier, 5, 10, yeah. So the length or the sum of this array is 11. And so let's just take the difference of x, which is actually 6 here. And so what this can imply, and I'll show you an example here where there's 6. So this is a window, often called like a sliding window in this pattern, and it actually has the difference here, or the sum of 6. So this window's value sum to 6, and then the total sum of the entire array was 11, we counted earlier. And so what this means is, whenever we see that there's a window size of 6, wherever it's found in the array, as long as it's contiguous, we know then that the difference here that's remaining is basically what you need to subtract from x to get to 0. And so that is true, in fact, because these sum to 5 here. And so we know in this particular case, with this window here, we just take the length of them, which is basically, this is a length of 3 and this is a length of 2. And so you basically just say the overall length is 5, our window size is 3. And so basically this current length, or the number of operations we need to reduce x to exactly 0, is 2. Another example of this would be right here. So this is another window where we found a that difference that we're looking for, which is our target, which is 6. And so we know that, okay, well, the length of this window is 2, the overall length is 5. And so this means we'll need to do 3 operations from outside in to reduce x exactly down to 0. All right, so I hope I explained it pretty well. We're basically going to shift this from left to right, the sliding window, and then wherever possible, we're going to kind of trim or shrink the left-hand side, which allows us to try kind of every possible valid combination in here, yet we'll still be hitting that O of n time complexity and O of 1 space complexity. So let's go ahead and implement it here. So what we'll do is first we want to calculate our target, which is just, once again, the sum of this array minus x. And so in this case, we're talking about, this would be like the number 6 here. So the sum of the numbers is 11, x, our target was 5, and so this would be the example that I just showed, 6. And so we want to keep track of 2 pointers, which is the start and the end of our window. And so the first pointer will be equal to 0, while the second pointer will be basically just iterating along here. So I think what I'll do is enumerate this, the numbers, just so that we can also pull out the current number. And so with this, we basically want to be adding this particular number to our window. And so we want to keep track of the current sum of our window. So we'll call this like window sum maybe. This is also is initially 0. And so with each iteration, we're basically ingesting a new number to our window. And so we want to say window sum. We want to add this number, and then to keep track of the size of the window, well, that's going to be P1 and P2 here. All right, and so what we want to do here is we want to return the minimum number of operations, which is basically just going to be the maximum length, or because we want to maximize the size of the window, because our window is basically the difference between this overall size and the number of operations. And so to get the minimum operations, you just get the maximum window size, and then we basically subtract the length from it. So the length of the numbers minus our maximum window size. And so initially, this is also equal to 0. And so whenever we see that the window sum is equal to our target, then we just found a new possible window that could reduce the number of operations that we need to do. So we want to continuously maximize this stat here, or this window size. So we say the max length is the max between the current maximum length and then basically the current window size, which is P2 minus P1 plus 1, just to get the edge case there. And with this, the only other thing that we need to do is we want to kind of dynamically, and this is kind of the main caveat with the sliding window pattern, is how do I want to kind of shrink the left-hand side, because with each iteration, the right pointer is growing, or P2 is growing. But at times, whenever we see that, okay, the window is getting too large and it's greater than our target, then we want to shrink our left pointer. Okay, and so we just say, okay, while P1 is less than P2, because we want the left pointer to always be kind of behind the right pointer. And then also that we see that our current window size, or the sum of our window, is also greater than our target. That means we don't want to ingest any more numbers, because our window will grow too much and it'll never hit our target if we keep adding numbers to it. And so we simply want to reduce our window sum. And so to do that, we just say, okay, window sum minus the number at our left pointer, which is P1. And then also we want to increment P1 forward, because we want to shrink the window size. All right, and so there are some edge cases here that we want to talk about. And so the first one is that, okay, if the, let's say the target is equal to 0, that means that we want to actually use the entire length of the array here. We want to use every single number to reduce x down to 0. So in that case, we just want to return this length of the numbers. All right, so we need to use every number in the array to reduce x down to 0. To reduce x down to 0. All right, and so the other case here is that we also want to be able to return -1 if we're not able to reduce x exactly to 0. And so we just want to say, okay, we simply return this if we have a maximum length. Otherwise, we want to return -1 because we weren't able to find a particular length that's non-zero here that was able to reduce it down to 0 or basically hit our target. So let's try running this. Looks good. And accepted. So yeah, I hope that helped a little bit. It's a totally performant algorithm and runs in O of n time and O of 1 space complexity. So yeah, hope this helped a little bit and feel free to follow for more. All right, thanks for watching.